There we go. Okay. Now you can hear me. Well, it's a good thing we checked because I just stuck it in my pocket and didn't even turn it on. That's so bad. That's okay. That's how it goes. Well, if someone wants to watch this video to learn how to do balancing equations, they can. We'll just go over this worksheet real quick. And if you have any questions while I go over it, straight off the bat, just ask them. But balancing equations is a pretty simple objective to learn. You just got to make sure that each side of your reaction, because you have your what is it? Products and what's the other one? Reactants. That's the word. You have your reactants on this side and your products, and you want to make sure that you have the same amount of atoms of each one on each side. Like off the bat, we can see that there's 3 chlorine on the product side, and there's only 2 chlorine on the reactant side. So we got to manipulate the coefficients, which is those big numbers in front, to figure out so that our equation is balanced. So what numbers can we put as the coefficients to balance out our equation? What do you think? Because we have 3 chlorine on this side and 2 on this side, but we have 1 and 1 iron. So we got to put in some numbers that will balance out so that we'll have like 9 on this side and 9 on this side, or 6, or just any number. Okay, 2. So if we put a 2, let's say we'll put a 2 on the product side real quick. That gives us 2 iron and 6 chlorine. So we obviously are going to want the same amount of iron right off the bat, which is 2 and 2. So we can just put a 2 in front of the iron. Then we got to figure out the number that we need for chlorine, which is pretty easy because we just do 2 times 3 is 6. So we just need another 3, right? It's pretty... Yeah, any number that, like the smallest, that works. The smallest number that'll work. I think it's, there was a name for it in math, like, oh, the least common denominator. You remember that? It's pretty much the same thing. But that was in algebra, maybe? I don't remember. I learned it a long time ago. Okay. We'll go to question B. We got iron, 2 oxygen, and then on the other side we got 2 iron and 3 oxygen. So, what numbers are we going to need?
Do you do 2 again? Or?
I mean, yeah. So do you want to start off balancing oxygen or iron first? Okay. So we have 3 oxygen on this side and 2 on this side. So the least common denominator, we can do the same thing here because it's basically there's 2 chlorine, there's 2 oxygen, there's 3, and there's 3. So we can figure that out pretty simply. So if we put a 2 with our products, that gives us 6. So that means we just put a 3 with our oxygen, and that gives us 6 oxygens on both sides of the reaction. Because you know the little arrow signifies a reaction took place. So then we just gotta have the same amount of iron, which is pretty easy. You do 2 times 2 is 4. And there's no subscripts, so we just go 4. That way we have 4 iron to interact with our other 4 iron. Now this is where the numbers get a little more complicated. It's the same concept. So we have iron and bromine. And so we have 1 iron, 3 bromine, 2 hydrogen, 1 sulfur, 4 oxygen on the reactant side. And then on this side, we already have 2 iron compared to our 1. And then we have 3 sulfur and 4 oxygen of that group. The sulfate, the name for it's the chemical name, you know, for sulfur binding with 4 oxygen. And that's not the right bonds. You know Lewis structures? Y'all haven't talked about that yet, have y'all? But yeah, that's kind of what it is. There's probably more, there might be double bonds and electrons out there. But that's its own molecule. But yeah, we have 3 of those. So that means we have 3 sulfurs, and we have 4 times 3, so we have 12 oxygens on that side. This is what that means, because there's the parentheses around that molecule, and so that superscript is basically saying there's 3 of these right here. There's 3 of those molecules. We just got to make sure that we know that those are multiplying so that we can also put in our coefficients too. Yeah, pretty much. So we have 2 iron on this side, and we only have 1 iron on this side. So we are going to want to have 2 iron. So we can put a 2 here to start off with. Whenever you balance equations, it's always good to use pencil and not pen, so you can erase just in case it doesn't work out, because we might not know if we need a different number here. But since we put a 2 here, that's maxed out our iron, so we don't need to put anything. Normally, you can put a 1 here, but if you put a 1, you can leave it blank pretty much. And so we have 6 bromines. Right, isn't that bromine? Am I crazy? No, it is. Yeah. Okay. Yeah, so we have 6 bromines on this side, and we need 6 on this side. So if we do that, we find the correct amount of bromines, but now we have our hydrogens. There's 6 hydrogens here, and there's 2 here. So that means we're going to need what number?
Wait.
We have, since we did the 6 right here, we have 6 bromines, and on this side we have 6. But now we're looking at our hydrogen and our hydrogen. So what coefficient do we need in front of our H2SO4 to get the same amount of hydrogens?
3.
Perfect. Yep, we're going to need a 3. Then we need to double check that all of our numbers work out, because we didn't even talk about the sulfur and 4 oxygens. So if we do 3 times 2, that's 6 hydrogens, and then 3 sulfurs, and 3 sulfurs, and then 3 times 4 is 12. So we got 12 oxygens and 12 oxygens on each side. And we know that our irons match up, and so do our bromines. So that's how you do it. Yeah. It's always good to work with a pencil, just in case you start off with like a number, and maybe we start off with 3 here and realize that's not going to work out because we're going to need a specific number of hydrogens. So because our hydrogen and bromine bonded, and they were 2 different molecules in the reactant. Okie dokie. You want to try and do D first and tell me what numbers you get?
Yeah.
Might as well, since we went over the first 3, and we can. Yeah, while you do that, I'll look up the Lewis structure just so I steer you guys the right way. Lewis structure for SO4. Oh gosh. So you got it? You think so? All right. What do you have for the first molecule? 1? Okay. Check in my answer key, and you are correct. What's H2O? What's our water? 1? Well, see, look at that. You're not half bad at it. Because as long as we check, we got the same amount of carbons on each side. We have the 8 hydrogens over here, and then we have 2 here and 6 here, so that's 8. And then we have 4 oxygens, right? Yeah, 4 oxygens, and then we have 3, and then 1 more is 4. So you did that one pretty well. You want to look at this list and tell me if there's another one that you want to go over quickly or not? You want to go H and J? H-I-J? Okay, we can do that. All right. Well, let's start off with our H. Let's start looking at our numbers. So I can already tell in my product I have a lot of hydrogen, silicon, and oxygen over here. So I got to check what numbers. I'm probably going to be manipulating these numbers to match up with this. So I might only just need a 1 right here, just because they're much larger numbers. So we have 2 hydrogen over here, 2 hydrogen over here. There's 8 over here. I could do 2 and 2, which would give me 8, but it would only have 2 silicone on this side and 4 on this side. So I need to match up my silicone, which is 4 here. So I should put a 4 here to match up my silicone, because that's the smallest. Because silicone's only in this molecule and this one here in the reactant side. So you have to make those numbers match up, because there's nowhere else. Hydrogens, we can fiddle with the numbers to see, because there's some here and here. But this gives us 8 hydrogens, and so we only have 1 oxygen here and 4 here. So the same thing that we did with silicone, we're going to have to do with oxygen, just so that our oxygens meet up, or so they match up anyway. We have 4 oxygens and 4 oxygens, but now we have 16 hydrogens, and there's only 8 here. But there is a 9th one over here. So what we could do is we could make sure we also have 8 chlorine here. So that means that our numbers will match up, because this makes 8 hydrogen, and there's 8 hydrogen here. So those cancel them, like they're the same. We have those the same. Now we just have to worry about this 8 hydrogen over here. And so we know that there's also 8 chlorine over here. So yeah, so I can just put an 8 right here. And what did you say? So, boom. You following along yet? Here. So this 4 and 2 hydrogen in the second molecule of the reactants makes 8. So I'm going to cancel it. In my head, I know that there's 8 right here and there's 8 right here. And so then I was manipulating this number with the hydrogen and chlorine in the products. You figuring it out? Okay. What's confusing about it? Well, because there's an 8 coefficient here, so there's 8 hydrogen and there's 8 chlorines. And so over here, it's just 1 of everything. So there's 8 and 8. And so if I look over here to what I got, I have 4 times 2, which is 8 right here, and 4 times 2, which is 8. So basically, I have 8 hydrogens, 8 hydrogens, 8 hydrogens, 8 hydrogens. And so that's how they equal out. They're balanced. Does it look good now?
Oh, okay. Yeah. I didn't see the
You weren't looking at the oxygen, or?
No, I wasn't. I didn't see.
Gotcha. Yeah, because the 4 gives us 4 oxygen, and our oxygen matches up on both sides. So yeah, that's why it's always good to work with a pencil, just in case. I've had it a couple of times where I've had to go back and start over. But yeah, so you want to do I and J.
We can see J.
You want to just do J?
Yeah.
I can show you I really quickly anyway. It's pretty simple because we got our larger numbers over here again, so we want to match them up. And there's only silicone. So I'm just going to put a 10 at the start. And that means that I'm going to have 10 silicone, and there's 15 oxygen, and there's only oxygen here again. So I'm going to put it 15. And here I have my, hold on, let me check. Yeah, so I have 1 hydrogen, 1 chlorine. If I go over here, I have 10 hydrogen, and I have 30 chlorine, but I also have 30 chlorine over here. So that means I can just do there's 10 hydrogen here and 10 hydrogen here. There's 30 here. So if I put a 30 right here, that means I'll have 30 chlorine, which will match up and balance my other 30 chlorine. And then I'll have 30 hydrogen and my 30 hydrogen, and there's 10 hydrogen. So that means I need to just leave this as a regular, the way it is. And that way I can double check. I have 10 silicone and 10 silicone, and then 15 oxygen, 15 oxygen. And so they match up. You basically want to start off with one atom and then work them out and make sure they work, and then move on to the next one. And as long as they all work, then you're good. If one doesn't work, you'll have to go back and pick new numbers. Pretty much. But yeah. You want to try J first real quick? No. You want me to do J? Okay. So for J, I can see that I have the same amount of carbons just right off the bat on that side. And then there's 6 hydrogen, 2 more hydrogen, that's 8 hydrogen, but there's 9 over here. There's 10 over here because there's 1 more. So I'm going to have to do some numbers around here. And I have my NO2, but there's a 3 there. So that makes 6 oxygen and 3 nitrogen. Well, I know if I just put a 3. Yeah, if I put a 3 here, it'll match up my nitrogens. Oh, now my oxygens are out of balance. So I also need to put a 3 here because I have 9 oxygens, and then this gives me 6, and this gives me 3 more. So now I have 6 hydrogens, and there's another 6, which is 12. And then over here I have 3 and 9, which is 12 again. So that means, and my carbons are the same, so I don't want to mess with either of these 2 molecules. You can leave them blank, yeah. When you're actually doing them, you can just leave them blank. But yeah. I mean, that's balancing equations. I have a bunch of practice sheets here and the keys on them. There's something like that. So, but yeah. I'm probably going to upload these worksheets online. So if anyone who's watching the video can download them and just copy them or print them off or do whatever. But since you're the only one here, you can have my copies. So how about that? But yeah, I guess I'm going to end this meeting so I can get the recording on it. And then if you have any other questions about balancing equations or something else, I can answer them before we go.